Bismillah ar-Rahman ar-Rahim. Today I'm going to talk about the measures of risk and how we measure the portfolio returns and portfolio risk. So please pay attention. I know some students have exams, but this is related to mathematics and it may activate your brain. As I said in the last meeting, the measures of risk, we have two measures of risk. We have standard deviation and beta. This is for your level. There are other measures of risk, like the coefficient of variation, like the values at risk, expected shortfalls, and many others. But for your level, we only focus on the standard deviation and beta. Look at the stock A and B. If you look at the stock A, it's starting fluctuated from 13.5 till 16.5. But if you look at the stock B, it's from 11 to 19. It means stock B is fluctuated more than stock A. If you converted this into a chart, you will observe in this chart we have stock A, okay, and we have stock B. Look back. For the stock B, this is the stock B, is highly fluctuated relative to the stock A. However, stock A and B have same average, which is 15%, but are highly fluctuated. Look at this chart. Look at this here. If we have stock A, for instance, is highly fluctuated, and if we have stock B, is less fluctuated. And if we take the average of stock A and the average of stock B, so this is the average. Let's see, for instance, this is 15% and this is 15%. And this stock is highly fluctuated compared or relative to this one. Why? Because the observations are far away from its average. But the observation here is not far away from its average. So the average, it could be the same, but the dispersion or the variation is different. The more the stock is fluctuated, the high risk the stock. If we calculate the sigma of B, and this is A, the sigma of this, sigma A, will be less than sigma B. Okay? How we calculate sigma? So this is our second task, how to calculate the sigma. Okay? So we measure risk. To what extent the return of stocks is fluctuated. Okay, how we measure risk if we are using this chart, to what extent these observations are far away from the average, and we can use the least square method. So the sigma, okay, is equal to the root of the summation of R minus R bar raised to the power 2, okay, divided by n minus 1. So we can apply this formula if we are using realized return. It means if we having historical data. But if we have non-historical data, we have the future data. It means we are using probabilities. Then the formula will be pi r minus r hat raised to the power 2. I will go to explain all of these equations. Okay. So just to think on the two stocks. In the terms of portfolio, if we combine the two stocks together, so the risk of both will offset each other. So we may obtain minimum risk. Again, we will go in details about these two things. Okay, so the expected rate of return is equal the expected dividends divided by the initial price plus the expected growth. The expected growth in this equation, is equal B1 minus B naught divided by B naught. If the price increases, it means we will say the price appreciates investors. But if the price decreases in the future, it means the price depreciates the value of stocks or depreciates the investor. Okay, so this is the importance of the. I explained this in chapter 1. Okay, just to put things in different ways. Just to remind you with the formula, the expected return is equal B1 minus B naught divided by B naught plus dividends divided by B naught. This one is the capital gains, which is the growth. Why we call this as the growth? Because it could be the growth of the stocks, growing in the stocks, okay? And if there is a growing in the stock price, we will say this is appreciation. And if the price go down, it means there is a depreciation in the price. Okay, and this is dividends, it's the current yield. This is the current yield. And this is the capital gains. And in other way, they call this is the growth. Okay. If we have example here, we bought the stock at $100 and sold it at 110, and the dividends at 4. So the expected return of this is 110 minus 100 divided by 100. So this is the growth plus the 4 divided by 100. So if I ask you very little question, what is the growth rate? The growth rate is 10%. And what is the current yield? The current yield is 4%. So in total, we obtained 14%. If we deconstruct the total return into two components, we will say the capital gains or the growth contribute by 10%, and the current yield contribute by 4%. Okay? It is not necessarily that the dividends contributes in the total return as well as the capital gains. It could be the dividends, could be the capital gains, could be both. Okay, so be careful. Okay. In case for the expected return, we want to anticipate the future in the terms of probabilities. Okay? Because we are not certain to have a particular return in the future, so we claim that to calculate this, we should consider the probabilities of economy. For instance, if we say in the boom, we will get 50% the boom occur in the economy, 30% in the intermediate, or okay, and let's see 20% as the recession. This is the probabilities of economy, and based on the probabilities of economy, the rate of return is determined. Okay, I will show you some example. Look at this example here. Look at this example here. So the example is If the state is excellent, so the probability of having excellent economy, 25%. Good economy, 45%. Poor economy, 25%. And the crash economy is 5%. If you sum these states, you will obtain 1 or 100%. And if this occurs, we will obtain 31%, 14%, minus 6%, minus 52%. To calculate the expected rate of return is the summation of BI times RI, or the summation of PS times RS. This is the stocks and this is the stocks. It's I, any I. It could be bonds, could be stocks, or any other things. So you just times the probability of the state by the return of the state. By doing this, we obtain the expected rate of return for a particular stock. Just 25% times 31 and 45 times 14, you will have the 9.76%. Okay? Just very simple. So this is the expected rate of return for a particular stock. For the terms of the variance and the standard deviation, if we want to calculate the, just to remind you, when I talk about the sigma, just the expected sigma in this case is the roots of summation of r minus r I raised to the power 2. If we have probabilities, just time by the probabilities. If we are talking about the historical data or actual or realized data, you just sigma is equal to the root of summation of r minus ri raised to the power 2 and minus 1. Okay, so so this is the variance. The variance is the probabilities, the same equations, by RS minus the expected rate of return. The expected rate of return in this equation is the R hat, or the expected rate of return that you calculated in like this. Okay, we will have questions about this. Let's go back to this case and do calculation for the sigma. For the sigma, just apply this equation, the summation of r minus r hat raised to the power 2 times pi. Okay? In this case, 31 minus 0.0976 raised to the power 2 times the pi is 25.25 plus 0.14 times 0.0976 raised to the power 2 times 0.45 plus minus 0.675 minus 0.976 raised to the power 2 times the probability is 0.25 plus the last thing minus 0.52 minus 0.976 raised to the power 2 times 0.05. Okay? So what is the result? And you get the results and under roots. Okay? Okay. So the standard deviation is the root of sigma squared. Okay? Do you have this? It is the same things. Okay. It's 0.038. Did you get this result? Okay, that's fine. So it's 0.038. If sigma is located below 1, it means the return of this stock follows a normal distribution. Okay? Pay attention, please, here. If the output of sigma is less than 1, it means the return of this stock or this security follows a normal distribution. Yes. Yeah. Do the roots. Yes. It's 19.1949. So it's 0.1949. It means the this data or the return of this stock follows a normal distribution. Why it's important to know follows a normal distribution? Because if our data not followed or is not followed the normal distribution, we cannot apply the beta or the standard deviation. We should apply other measures of risk, like values at risk and expected shortfalls. Okay, so but in your level, it's fine to know that we cannot apply the normal distribution. Okay, so now just to summarize things, we know how to calculate the return of a particular stock, how to calculate the standard deviation for a particular stock. Now we will try to know how to calculate the return and the standard deviation for a portfolio. Okay? This is very important to know. Let's just think, if we have $1,000 and invest this $1,000 in this way, 400s in A and 600s in B. Okay? So the sum is 1,000s. It means 40% in A and 60% in B. The 40% in here is the weighted average, the weight, and the 60% the weight of B. To calculate the rate of return or the expected return of portfolio, the expected return of the portfolio, it's similar to the individual stock, but we should consider the weighted average of the stock. If I give you additional information, the return of A is 7%, the return of B is 12%. So what is the expected return of the portfolio? The expected return of the portfolio is the summation of WI, RI plus WJ, RJ plus WN, RN. Okay? Very simple. It's the weighted average of return. So here the expected return of the portfolio having two assets or having two stocks is 0.4 times 0.07 plus 0.6 times 0.12. So this is the rate of return of the portfolio. Okay? It's very friendly calculation. Any question? Okay. Okay, take this example. Okay. Look at this example here. stock 1, this portfolio having 3 stocks, okay? Stock 1, 2, and 3. And the weight of each one is 25% for the first, 25 for the second, and 50 for the third one. Be careful, the weight must be 1. Okay? So now, what is the expected return of the portfolio? It's very simple. Just times 25 times 8.3, and at the end you get 10.87. This is the expected return for the portfolio. But calculate the sigma, or the standard deviation of the portfolio, is not as friendly as the return of portfolio. The answer why? Because the calculate the standard deviation is a subject of correlation between the risk of the stocks. For instance, if we have this portfolio with the 2 assets, A and B, the return of A and B has no correlation, but the error of A and B has a correlation. Or let's see in a different way, the sigma of A and B has correlation. So in this case, when we are forming the portfolio, we should be careful of the correlation between the sigma of A and the sigma of B. The sigma, which is called rho. The rho is the covariance of sigma A, sigma B. Okay? And this covariance is located somewhere between +1 to -1. The covariance, the rho, or the correlation. Okay? The correlation. So the correlation between the standard deviation of A and the standard deviation of B is located between +1 and -1. +1 is completely perfect or perfect correlation, and -1 is negative perfect correlation. Okay? Now, so the correlation is a statistical measure of relationship between the 2 series of numbers of representing data, in particular for sigma. Okay? And we have positively correlated is moving together, is like this. If we have stock A and stock B moving like this. And negatively correlated is like this, moving against each other. Let's say use a different color. Okay, this is A, and this is B. This is negatively correlated with the and the efficiency of portfolio depends on the correlation between A and B, or depends on the correlation between the combination of assets in the portfolio. We expect to have less correlated assets, because the less correlated assets generate less sigma squared, or less standard deviation. So we prefer to have less standard, or less rho. So the correlation coefficient is a measure of the degree of correlation between 2 series of numbers representing the data. As explained, we have positive correlation, and we have negative correlation, and we have uncorrelated. Uncorrelated, the rho is 0. Okay? So look at here, this is positively correlated, moving together. Okay? This is perfectly negatively correlated. They move against each other. Okay? What is the importance of correlation? To reduce overall risk in portfolio, it is best to combine assets that have a negative correlation, less correlation, or low positive correlation. We prefer having low correlation or negative because the less correlated assets have less risk, or sigma. Uncorrelated assets, which have zero rho, reduce risk somewhat, but not as effective as combining negatively correlated assets. So the efficient portfolio or the efficient managers, they try to locate assets that having negatively correlated or low correlation. Investing in different investment with high positive correlation will not provide sufficient diversification. In order to diversify between assets or among assets, we should look for the negative correlated assets. Okay, so how to calculate the sigma? As I told you, calculate sigma is not as smiling face as the return of portfolio, because the return of portfolio, as I said, the return is not influenced by each other. I mean the combination of assets. When we calculate the return of portfolio, the return of the portfolio is the WI times RI plus WJ times RJ, okay, plus WM RM. But we cannot say this in that's WI sigma I plus WJ sigma J WN sigma M. So this is totally wrong. This is totally wrong because the sigmas are influenced by each other, and it generates correlation. Okay, so we should to recalculate the sigma B or the sigma of portfolio by considering the correlation between the assets. Okay, just to simplify things, consider we have two assets, A and B. A have R and sigma, and this is R having R, and this is sigma. To calculate the sigma of B, the sigma of the portfolio, the sigma of B is equal the W of A, WA squared, okay, W of A squared, sigma A squared, plus WB squared, sigma B squared, plus the WA, WB, the covariance of AB. Okay? Now let's deconstruct the covariance of AB. The covariance of AB, as I told you before, it's the covariance, the relationship between the sigma of A and sigma of B. Okay? So, sorry, here we have two. So sigma A times sigma B, rho AB. The standard deviation of A and the standard deviation of B and the correlation between A and B. Okay? So we write back or rewrite the sigma of B, the standard deviation of the portfolio, WA squared, sigma A squared plus WB squared, sigma B squared, okay, plus 2 WA, WB, sigma A, sigma B, the rho AB. Okay? Any question? You don't need questions. Okay? This is for if we have only 2 stocks. But if we have 3 stocks, things become more smiley. Okay? So let's consider 3 stocks. But in general, if I ask you, just ask you about two stocks. So this is the good news. If we have 3 stocks, A, B, and C. And if we have 10 stocks, the good news Excel do this properly. Yeah, I will show you how Excel in the financial analysis, how Excel deal with this. Okay, let's rewrite the equation based on the 3 stocks. If you have 3 stocks, just you have A, B, C. So A with B, A with C, and you have B with C. Yes? So you have 3 alternatives. A with B, and A with C, and B with C. But if you have A, B, you have only A with B. A with B. But for 3, A, B, A, C, B, C. Okay, in this case, sigma B is equal, don't forget in the previous equation, just put them under roots, because this is sigma squared. Okay, sorry for this. Is WA squared, sigma A squared, plus WB squared, sigma B squared, plus WC squared, sigma C squared, plus now 2 WA, WB, sigma A, sigma B, rho AB, plus 2 WA, WC, this is, okay, WC, okay, sigma A, sigma C, rho AC, plus 2 WB, WC, sigma B, sigma C, rho B, C. That's it. If we have 4 stocks, okay? If we have 4 stocks like this, A, B, C, D. We have A with B, we have A with C, we have A with D, and then we have B with C, we have B with D, and then we have C with D. Okay? We have C with D, so D with A is here, D with B is here. Okay? Okay? So we have D with B, okay? And we have C of D is available. Okay? So you have to go through this. So the good news, I'm not going to ask you about the 4 stocks, just 2, and if you are lucky, you will have 3. Okay? So just very simple. It's not that much. Yeah. Okay? Any question for this? You should train yourself about how to calculate. Okay. Calculate the standard deviation. Determine the expected return and standard deviation of the following portfolio consisting of 2 stocks that have a correlation coefficient of 0.75. The correlation coefficient is rho. Okay, we have Apple and Coca-Cola. The weight is 0.50, 50, 0.14, 0.20, 20. It's very simple. So the average is 14 for the portfolio, because the 2 stocks, Apple and Coca-Cola, having the same average rate of return, and they having the same standard deviation. But look at here. The risk is influenced by the rho, 0.75. So, if there is no correlation between Apple and Coca-Cola, we should observe that the standard deviation must equal 0.20 if we avoid the correlation. But because of a correlation which is 0.75, we should observe decrease in the standard deviation. Look, So this is the expected rate of return, just times, very simple, okay? And look at the standard deviation. The standard deviation is 18.7%, okay? 18.7%. Try to 0.20 times 0.75. Do the calculation, please. 0.20 times 0.25.
75.
Yes, 75. 15. Yes. Okay. So the rho, or because of the presence of rho, it makes the correlation, or sorry, the standard deviation to decrease. So the range of rho is located somewhere between the 1 to -1. Okay. Any question in here? We will take some examples just to. Okay, we'll see this. You can open page 146. For the year 1, year 1, 2, 3, 4, the R of A, the return of A is minus 15%, 12 in the second year, 25 in the third, minus 37 in the fourth year. Okay, and RB is 25%, then minus 2, minus 15, then 13.75. Okay, now asking you a little question, and the weight average for A and B, the weight of A is 0.5 and the weight of B is 0.5 as well. The rho is -1. The rho is -1. Now look at before considering the rho, look at the return of A and the return of B. In some questions, I ask my students to predict the rho. I give them two options. For instance, the rho could be 0.80, for instance, or minus 0.80. And based on your assumptions, calculate the return of portfolio and the sigma of portfolio. Okay? Now, look at the return of A and the return of B. What do you think about the correlation? Negative. How is negative? Explain this, please. How?
Minus 15%.
Minus 15?
And 25 positive in the
Okay.
positive.
When this increase, this decrease. And when this increase, this decrease. And when this decrease, this increase. Which means that the correlation is negative. Okay? Now, considering that the rho is -1. Now, what is the return of B and what is the sigma of B? Okay? The return of B, the return of portfolio, and the sigma of portfolio. So do the calculation, please. This side do the return of B, and this side do the return of A. Okay? Or you can do them one time. You cannot do this because this is portfolio. Oh, this side do the return, and this side do the sigma. Okay? So the return of B, you can do it in different ways. So you can do like this: RA, RB, the portfolio, okay, which is 0.5 times minus 0.15 plus 0.5 times 0.25, and you can do the rest and take the sum. Okay, 0.5 times minus 0.15 plus 0.5 times 0.25. Okay, and you do the rest. What's wrong? The second, 0.25 times 0.12 plus 0.25 times minus 0.02. The second, 0.5 times 0.25 plus 0.5 times minus 0.15. The last one, 0.5 times minus 0.37 plus 0.5 times 13 or 0.1375. Okay? And then you have the answer. What is the answer? It's 4.75%. 4.75%. Now you need to calculate the standard deviation because you want to calculate sigma. You need sigma A and sigma B. Yes? Yes. What is sigma A and what is sigma B? Okay. Before sigma portfolio, do sigma B. And sigma B is the root square, okay, of r minus r hat raised to the power 2. Okay, divided by n minus 1. Just use this equation. And again, it's equal for, the sigma of A, which is equal, the root of r minus is minus 0.15. In this case, you need to calculate the average of this. The average of it's 5%. Check the answer, please. And the average of is 4.5%. So minus 0.15 minus 0.5 raised to the power square plus 0.12 minus 0.05 square plus 0.25 minus 0.05 squared plus minus 0.37 minus 0.05, okay, raised to the power square. All of them divided by n minus 1. The roots divided by n minus 1. Okay? Sorry? Which one? This one. Okay. Why? Oh, this different question. Do it again. You will have different answer. It's minus 3.75. Minus 3.75. Okay, and this one is 13.75. 13.75, and this one is 5%. Check the calculation, please. Okay. To calculate the standard deviation of A, we have 25% minus 2 minus 15. Oh, yeah, this is 47. 47. Sorry for this. So 9. Yes, the R of A, R of V. Okay. For the first one is fine. And these are the answers. Now the sigma. This is the R of A and R of B. Now for the sigma is 27.73 and the 27.3. Would they have same sigma? Okay, calculate now the sigma. So calculate now the RB and sigma B. Now it's done. So you have the information. WA is 0.5, WB is 0.5, the rho is minus 1. So now what is the R of the portfolio? Okay, R of the portfolio is 0.5 times minus 0.0375 plus 0.5 times 0.1375. Okay. The sigma of P in this case is WA squared sigma A squared 0.5 squared. Okay, sigma squared WA 27.73 squared. Okay, plus 0.5 squared times 27.73 squared plus 2.5 times 0.5, okay, times the standard deviation, the 27.73 times 27.73 times minus 1. Yes. So the results, look, because we have the correlation is minus 1, so the result will be point. Are you sure? The sigma squared. Oh, sorry, sigma. Do the calculation again, please. Do the calculation again. It's fine. Now, 2. Yes. Do the calculation, please. The return of the portfolio is 5%, yes?
No.
Huh?
Yes.
Yes, but the sigma of the portfolio, when you have minus 1, be careful in the calculations. So, sorry? 5 squared. Look at here. 2. It must be 0. the sigma squared or the sigma of B must be 0. Okay? So the answer will be 0. The answer of this, 0. Yes. Because the correlation is perfectly negative. Okay? Any question? Check the calculation. We will stop here. Okay? And the next meeting, I will talk about beta and other, sorry, 0, yes, and other measures. Okay, any questions?